I should send that email. That's funny.
He called me a shill.
Hmm?
This guy called me a shill because I use Scilab and not Matlab.
Oh, I use Scilab also. Why is it a show?
He's always trying to sell me on this idea.
Oh.
Yeah, using Matlab, so
Unsuccessfully?
cheaper.
Oh, maybe the French.
English documentation that I use. Works. Good enough.
Try not to knock this down. Is it on? Okay. I mean, it's almost a like a clone, right? The codes are line by line the same, just with tiny bits annoying syntax difference that you can't just run it otherwise. Yeah. So it makes you wonder, why should Matlab be so expensive? It's for educational purpose. Okay, so so let me tell you what I did last class. That we spent first 25 minutes about on new topics, and then we did a review, and it turned out they didn't really have many questions for me, so I'm going to run a similar setting. Is that okay? The review doesn't take that long. Seems like the review package is so detailed that people are okay. So I plan to do that as well, okay? So, anyone notice I have a new iPad?
Oh.
iPad Air 2. Just having fun, yeah. It took me a while to set everything up and get online and all that. Okay. Okay, so let's cover the Romberg algorithm today. I try to explain in detail to you how this wonderful another triangle can be set up, okay? So from last time, we'll pick up from there, and then we use that idea again and again and again into many layers and into an algorithm in the end. So last time, okay, so what we did was we built something on top of this trapezoid rule with the different grid size each time you have it, right? You're not having a question, are you?
Yeah, I have a question about the exam on Friday.
Yeah, I will do a review in the second half. After 20 minutes, we'll talk about it. Can you wait until then? Don't forget your question. Yeah. Let me write one more. So if you have a bunch of trapezoid approximation, each time the h is halved, like that. I wrote out 4, and you see you can maybe compute 5, 6, 7, y, as long as you can. Well, even though at the end the number of intervals grows exponentially with the 2 as a base. Okay, so 2 to the power n. Okay, and then last time we noticed that we could do this approximation, say use these two. I could construct a UH in the following way. So 2 square of T F with H half minus T F H divided by 2 square minus 1. Okay, it might be silly to see me write 2 square minus 1 or 2 square, but you'll be happy in the end, because this tells you the 3 down here is 2 square. Okay, and later on it will be a different number there, and then you see the pattern. Okay, so we figured out last time that it was our goal of our manipulation that this, we kill the leading term for the arrow, and then we bump up the order by 2. This is a 4th order approximation. Okay, so which means I have this identity. The integral, the one I wanted to compute, is approximated by this u of h, and then I have some arrow term. So which is fourth order, start with A4. I thought I used A4 bar, right, last time. And then I have a 6 bar, H6 plus many other terms, okay? And then the leading term is H to the fourth. So this is a fourth order approximation. Okay, so we're gonna borrow the same idea, okay? Just a very, very tiny, slight variation on that. So not only did we know that this is a higher order approximation, also the derivation gave us a detailed arrow formula for this guy, right? We know the leading term is H to the fourth, and after that is H to the sixth. We have a lot of information here. Okay, so what we do now will be, okay, so if I use this guy and this guy together, as we did with these two t's and constructed the UH, we could use these two in the same way and we'll constructed another U. So let's say now I compute another one. So this is UH, then this would be UH halved, right? The grid size will be halved. Is that clear? I compute the same thing with the t and the t here with a smaller h. Okay, so let's say I compute UH half in a similar way. So then I will have a similar arrow analysis for this guy. These will be similar except changing h into h half. So I'll have A4 bar h half to the power 4 plus A6 bar h half to the power 6 and so on. Is that clear? So that's 3 and that's 4. So we do the same thing. I want to cancel the leading term in the arrow, which means this term, I'm sorry, and that term, by some manipulation, I want them to be gone. So what should I do? You guys shall be pro now. What can I do? Okay, tell me, equation 4 shall be multiplied with what factor? So that 2 to the 4th. Then this term will be the same as that term. When I subtract, it will be gone, right? Is that clear? 2 to the 4th minus equation 3. Is that okay? So on the left-hand side, now I have 2 to the 4 minus 1 IF equals to 2 to the 4 UH half minus UH plus, and the leading arrow term is gone. What I have next is the term involving h to the 6, right? It's some kind of a6 times h to the 6 with another constant in the front. Can I call those a hat of 6? It's just some other constants. What matters is h to the 6 and so on. Is that okay? Okay, now I'm going to divide this factor on both sides. So I have IF now equals to 2 to the 4th UH half minus UH of 2 to the 4th minus 1. That's the first term. And then, well, this a to the hat of 6 is divided by that number. Let's call it a double hat, whatever, how many hats you want to put on it. It's a different number. It's a constant. Okay? It's the h to the 6 that matters. So what have we arrived? Let me call this guy v of h. Okay? So I know that the integral of f now can be approximated by this v of h with the arrow of what order? Well, it's dominated by the first term. So it's a 6th order. Is that clear? 6th order. That's a very high order, isn't it? So you see that, well, if I don't have to stop here, as long as I have enough t's for me to generate a sequence of u and then the sequence of v, I can do the same thing on v and keep going on until I don't have any more numbers to to work with. Do you see? So at this level T here, to use that to compute U, I make one less because I have to use two combined to generate one, right? I get one less. And with all the U to generate V, V will be one less than U, total number. So each time the number gets smaller and smaller, and you can see in your head a triangle being built up. Does that make sense? I can do the same thing here on top of V, and with this arrow formula, I manipulate and get rid of the h to the 6, I will get an 8th order method, right? Okay, so this in the end leads to the Romberg algorithm, Romberg method, whatever you call. Okay, so let's set it up. So I'll initialize the method. So this in the end, I will be making a triangle shape of it. So I have to, let's set up, initialize it, set, I'll call the h simply equals to b minus a. I start from the whole interval and then cut it in half and then cut into 4 pieces and 8 pieces and so on. Okay, so I set that and then I'll do the Romberg. So the first column here in this matrix, we're going to use a matrix to store triangle. So the first column here, that's R1, 0, R2, 0, Rn, 0. So the first index is for the rows and the second index for the column. Okay, so this is the first column. There you throw in all those trapezoid approximations. So the trapezoid for f with this h, and this will be the trapezoid f with this h half, and this will be trapezoid f h2 square all the way down will be trapezoid f h2 to the end. So you initialize, you fill in the first column. Then you can go on to do the next column. So what's in the next column here will be all those u's, the one we derived last time. So to compute one of them, you need information from two previous ones. You can use this and this to generate a u, right? So we're going to use this, we'll do a lower triangle, okay? So with this and that, I will compute the 1, 1, okay? So this will exactly be the u of h, okay? Computed by that formula, okay? And you can do the same thing. This becomes 2, 1, that will be the u of h half, and so on, then you get r of n 1. Is that okay? Okay, so this is the column for u, and then the third one will be the v that we computed today. You will use these two to construct this one, so r2, 2, isn't it? So that will be the one that we called v today, but this uv now is not essential anymore because we'll put everything in this R matrix here. Okay, it's the index that matters. So I'll have n, 2, okay? And then you can keep doing it until you have only 2, and then you computed the last one. Right? You have a triangle. That's the Romberg triangle. Is that okay? I still have to give you details of the algorithm though. Okay, so let's take a look at all these values in this triangle. What are they? They are all approximations to the integral you want to compute. Is that right? All of them are approximations. Some are better, some are not so good. So look at the first column here. These are trapezoid rule approximations with different grid size. So among all of these, which one will be the best one? As we go down, what happened to the grid size? It gets smaller. So it gave you a better answer. So this is the best one in this column, right? And then the second column, that's the best, right? And each column, the lowest one is the best. Okay, so let's compare this one with this one. Which guy is better? It's obvious. We compute this based on that, and this is of a higher order, right? So you go further to the right in the same row, you get better and better approximation. So in the end, once you have generated this triangle, it's that last number you are after, all right? That will be the best approximation. Okay, so let's say best one, best approximation here among all of these. Okay, so in the end, you end up with just an algorithm telling you how to fill in this matrix. So in a matrix position ij, say, let's say this is not 2, 1, this is ij. How do I compute this? Or say this is ij. I would use 2 numbers from the previous column. Is that right? And I do this computation. That will be for the second column, and this will be for the third column. And you see, all you need to change is this number, right? Second column, 2 times 1. Third column, 2 times 2. Kth column, 2 times bracket k minus 1. Is that clear? So I'm going to give you this general form. So the r at j, k, let's use these, will be computed based on the one earlier. So let me write it out in a for sure correct way. So 2 to the power 2 of the column number minus 1. You know, I cannot do that because I used the 0 as the index. So this is column 0, this is column 1, and this is column 2. So in column k, I will have 2 to the power 2k. But when you code it in Matlab, make sure to change it because you cannot start from 0, all right? Because I started with that notation. So I'll have to put 2k here. But remember, this k can go to 0 in my notation, all right? So the previous one, r at j, k minus 1, the previous column, minus r, the column, the one up, and the one on the left. That's the numerator, and the denominator will be 2 to the 2k minus 1. So that will be the algorithm that will allow you to generate this matrix. So let's take a look at this algorithm. So all you needed to compute a number here is a number up there and a number to the left. So you actually have a choice here. You know you have to do 2 for loops. A double for loop is needed. You could go through each column, compute the first column, initialize, and do the second, and do the third, all the way to the end. Also, you see that you can do row by row. You can compute, right, the first row, this is there, and then you come to the second row, you fill in this one, and you compute this using these 2. Then you can go to the third row, you fill in this one, compute this with these 2, compute this with these 2, and you keep going down to the last. Is that clear?
Why wouldn't you just, oh, okay, no.
Index?
I was going to ask, why wouldn't you just specify the last 2 trapezoid rules at the beginning and then just go the other way? But you do need all the way up to 0.
Yeah. But the for loop, you have a choice. Either you do column by column or you do row by row. It's a sequential method. You have to go in sequences, but you can choose this sequence or that sequence. Either way would work. Right? So let's give the last part accuracy. Okay, so if I take out this piece r of j, k, what will be the arrow term? Well, this arrow will be of order h to the power 2 of m plus not n plus 1, sorry, k, the column number. The column number is what's important, right? And what is this h? This h is how many subintervals you already have at the kth level. Is that okay? Okay. So in the lecture notes, there is a pseudocode given to compute Romberg as a function. So it's given as a pseudocode, not exactly following Matlab syntax. So there will be a homework problem there in your next homework, the one after the exam, that you will be asked to code in the Romberg. Okay, so you can start with this pseudocode, and the pseudocode is given using column by column. You can follow it, or if you prefer row by row, take it as a challenge, rewrite your pseudocode, do it row by row. You're welcome to do that. Okay, and I will not go through this pseudocode today. We'll go through it next time on Monday when we look at other MATLAB related topics. Okay, and I will show you some results. Okay. Any questions on Romberg? How are we doing with the other homework that's due on Monday? Nobody has looked at it? We're focusing on the exam?
Wait, maybe push that back because of phone.
Yeah.
Because like we're doing the test on Friday, and then like most of us won't be like doing anything except for phone for the weekend.
To like Tuesday, make an online submission.
Yeah.
It's okay. I don't think the grader will be so angry if you can just submit. I think she'll be okay with it. Yeah, I know. Yeah, but we'll talk about the exam now. I would say there's nothing to worry about. Well, no, don't quote me on that.